Hello, in this video we are going to go over the solution of the problem 1710, maximum units on a truck. Imagine that you have a truck and you can carry limited number of boxes on the truck. That number of boxes that your truck can carry is given to you by this variable, truck size. Here is 10. It means that I can carry 10 boxes with my truck. And also we are given a couple of boxes, and these boxes have different numbers and different values. The information about these boxes are in this matrix, box types. And the first element for each one is telling you how many boxes exist, and the second one is the value. For example, you could say, if I carry this type of box, I'm gonna be paid $10 for each box. Or this one is only $5, this one is $7, this one is $9. So the second elements are the values, and the first elements are the existing number of those type of boxes. And our intention is to get the maximum money. So the idea is this: I'm going to go and select the box type with the maximum value. I'm gonna go and say, okay, between 9, 7, 5, 10, 10 is maximum. I'm gonna go and select all of the boxes of that. So I have 5 boxes. So if I select that, I still have 5 empty. Then I go for the next highest profit. I go for example, 9. And I say, oh, okay, for 9, there are 2 boxes. 5 plus 2, 7. So far we use 7. And then we go for the next type, that is 7. And for 7, I can carry 3 boxes. What we are going to do is that we are going to consider the second element, and based on which one is highest, we are going to fill our truck. Okay, let's start writing the code. Okay, we are going to write this function maximum units, and the input to that is box types, which shows us the number of boxes and their values, and also our truck size is the maximum number of boxes that we can carry in our truck. So let me just print at the beginning this box types. As we are intended to use the boxes with maximum profits, and those profits are on the second element, so what I'm gonna do is to sort this array based on the second element. So we just say box types dot sort, and we say key equals lambda x x1. Also, I'm going to sort them based on the descending order. So I say reverse equals true. Okay, let me run it. I had this as the original one, and now we sorted that based on the second elements. I get 10, 9, 7, 5. Also, I'm going to return at the end what is the maximum units or maximum value. Let me define a variable for that. So I say value count equals 0 at the beginning, and at the end I'm just gonna return this variable. Okay. Now I'm gonna start a for loop and say for box type in box types. So we are visiting element by element. Okay. Let me also print box type. Next, I'm going to define a variable and say box count equals. So we know that we have different amount of boxes. For example, for the box value 10, I have 5 boxes. But how many of 5 I can use? It depends how many empty spots I have on the truck. So we are going to return the minimum number between the truck size and the box type 0 index. 0 index, for example, is 5. Then I look at the truck size. Truck size is 10 right now because we are at the beginning. And this one is 5. So we say, okay, I can use all of the 5. But there might be a situation that truck size would be less than the number of available boxes. So we are just going to consider the available empty spots as the box count. Okay, so let me also print box count. Next, I'm gonna update my value count and say value count plus equals box count times the box type second index. Why second index? Because second index is the value of that. For example, here value is $10 and I use 5 of that, so it's gonna give me $50. Okay, and I'm gonna add that $50 to the value count. Let me also print value count here. Also, as I'm adding these boxes to the truck, the remaining amount of the spots on the truck is gonna shrink, so it's gonna get smaller and smaller. Say truck size minus equals box count. Because for example, I used 5 here, now I have to reduce that from 10, so it's gonna be 5 empty spots for the next iteration. Okay, so let me also print the truck size. Also, if the truck size is 0, you say if truck size equals 0. In that case, it means that truck is full, so we just break. Also, you can consider it equals 0 or negative, but it's not gonna be negative. It's always gonna stay at 0 at minimum, because here the number of boxes we add is always the minimum between truck size and box count. So, and we just reduce the box count from truck size. Because of that, our truck size at the minimum is gonna be 0. But it doesn't hurt if you just use the less equals to 0 if it is negative. So it's gonna be same thing as equal to 0. Okay, let's run it. At the beginning, we had these informations about the boxes, and then we sorted them based on the value 10, 9, 7, 5. Now we have these sorted boxes. We loop over that and we get the first element 5, 10. I have 5, 10. I'm gonna add all of that. Because I'm adding all 5, I'm gonna get value 50, and our truck size is adjusted to 5. Now I go to the next element 2, 9. 2, 9, I'm gonna use both of that. So I'm gonna use both of that. So it's gonna be 18 as the value. 18 plus 50 is 68, and our truck size is still 3. We go for the next one, 4, 7. How many I can use? I can use only 3. That is this minimum. Because we only have 3 empty spots on the truck. So I'm gonna use the 3. And 3 times 7 is 21. 21 plus 68 is gonna be 89. And our truck size now is updated as 0. So truck is full, and we just return the value count, which is 89. Let's talk about time and space complexities. For time complexity, the order is n log n, and that's because of this sort function that we used here. And for this for loop here, we just get order of n. So as a result, the time complexity is n log n. For the space complexity, order is n, because we are using sort function in Python, and that requires n spots for the sort. Okay, this is the solution of the problem 1710, and thank you so much again for watching this video.